Sir, hello sir. Sir, sir, your voice came down. Hello sir. Hello. Sir, came down. Hello. Sir. Sir, your voice கேக்குதா மட்டும் கொஞ்சம் செக் பண்ணி மட்டும் சொல்றீங்களா? நான் இங்க கனெக்ட் பண்ணிட்டேன். Sir, கேக்குதா sir? Hello.
Hello sir. Sir.
கேக்குது.
Okay sir. Then okay. Okay, thank you sir.
கீழே மியூட் இருக்கும் பாருங்க மேம். கீழே அதை க்ளோஸ் பண்ணிக்கோங்க. Dear authors, ma'am, Lakshmi ma'am.
Sir, சொல்லுங்க sir.
மேம், அவங்க ஆத்தர்ஸ் மட்டும் இல்ல, கோ ஆத்தர்ஸும் வர சொல்லுங்க மேம். நமக்கு
யார்ட்ட சார்? நான் லக்ஷ்மி.
லக்ஷ்மி தான், உங்ககிட்ட தான் மேம் பேசுறேன். கோ ஆத்தர்ஸ்
சார் யார்ட்ட சொல்லணும் சார்?
ஜஸ்ட் ஜெனரலா சொல்லுங்க. நீங்க ஜெனரலா சொல்லுங்க. கோ ஆத்தர்ஸும் லாகின் பண்ண சொல்லிக்கோங்க.
ஓகே ஓகே ஓகே.
நான் அவங்களுக்கு எல்லாம் நான் லிங்க் அனுப்பிட்டேன், மெயில் பண்ணிட்டேன்.
ஓகே 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 சார். ஓகே, டைம் இஸ் ஓகே.
கார்த்திகா, நீங்க பிரசன்டேஷன் யார் வேணாலும் பிரசன்ட் பண்ணலாம். ஓகே. Salma Elsadik. Salma?
Yes.
Can you hear? Actually, you're from South Africa, right?
No.
No, from which country you're coming?
I'm from Egypt, but I
Egypt.
live in Saudi Arabia.
Saudi Arabia. Actually, which university? Yeah.
Jubail.
And I'm not able to get you. Name of the university? Your university is?
Name of the university, Imam Abdurrahman bin Faisal University.
Okay. Actually, you are PG scholar or you're doing a PG or PhD?
It's
You're
a
a scholar.
presentation of what?
Yeah.
I can't understand.
You are a faculty or a scholar? Hello? Hello?
Yeah, I'm here with you.
Actually, you are a scholar or a PhD scholar or PG scholar or faculty in that university?
I'm student.
Okay. Thank you.
Okay.
Good morning, sir.
Good morning, ma'am. Good morning, ma'am.
Okay.
Good morning, sir.
Good morning, ma'am.
Video இல்ல சார், கேமரா
தேவையில்லை மேம், விட்டுருங்க. போட்டோ எடுக்கிறதுக்கு தான் வேணும்.
Good afternoon, sir.
Good afternoon, ma'am. Yes. Ma'am, Prabha, Felix வந்துட்டாங்கன்னா can start.
Yes, sir. She is about to join, sir. நான் இப்ப கால் பண்ணிட்டேன்.
Okay, okay.
Yeah.
Participants, please, co-authors can also join the meeting. So we have sent a mail to your mail ID also. Participants, please ask your co-authors also to join the meeting. Twenty-five, sir.
28, ma'am. Yeah, Felix ma'am வந்துட்டாங்கன்னா we can start, ma'am.
Struck out.
வந்துட்டேன் சார், ஜாயின் பண்ணிட்டேன்.
Okay, ma'am. Okay, ma'am.
Still work.
Ma'am, Sujawuddin sir.
Yes, sir.
Actually, இப்போ இருக்கிற கமெண்ட்ஸ் கொடுக்குற கமெண்ட்ஸ் அதை எழுதிட்டு according to that they have to change the paper. அது மட்டும் சொல்லிடுங்க.
Right, sir. According to that,
comments given by the jury members. அந்த கமெண்ட்ஸ்க்கும் அவங்க ஆன்சர் பண்ணணும். அந்த பேப்பர் தான் பப்ளிஷ் ஆகும்.
Right, sir.
அதனால அதை நோட் பண்ணிக்கணும், அது முக்கியம்.
அது வந்து நோட் பண்ணிட்டு கான்ஃபரன்ஸ் அதை நோட் பண்ணிட்டு நீங்க அவங்களுக்கு ரிவ்யூ கமெண்ட்ஸாவே கம்யூனிகேட் பண்ணிடுங்க சார்.
சரிமா.
சோ தட் அது உங்களுக்கு கவுண்டபிளா இருக்கும். அவங்க அதை நோட் பண்ணி வச்சு கரெக்ட் பண்றதை விட
நம்ம பண்ணிக்கலாம்.
நீங்க வந்து அந்த ரிவ்யூ கமெண்ட்ஸா நோட் பண்ணிட்டு ஈஸிச்சர்லயே யூ கேன் ஆட் இட் as additional reviewer. அந்த ரிவ்யூ கமெண்ட்ஸ் நீங்க அவங்களுக்கு த்ரூ ஈஸிச்சரே யூ கேன் கம்யூனிகேட். சோ டாக்குமெண்ட் ஆவறதுக்கு ஈஸியா இருக்கும்.
ஓகே மேம். ஓகே.
Sir, you can start, sir.
Yes, ma'am. Yes,
நான்
ma'am.
ஒரே ஒரு கால் மட்டும் அப்படியே லைன்ல இருக்கும்போதே பண்ணிக்கிறேன்.
So Sujawuddin sir, you can start. Value ma'am.
Lakshmi ma'am, you can start with the thing. Yeah.
Okay. So welcome back. Good afternoon to one and all present here. We will have paper presentation session starting from 13 hours to 15:30 hours Indian Standard Time. I would like to invite the session coordinator, Dr. N. Sujawuddin. We welcome the session chairs, Dr. T.T. Mrinalini, Professor, Dr. D. Thenmozhi, Associate Professor, and Dr. B. Prabhavati, Associate Professor of CSE Department for the paper presentations. Over to the session coordinator, Dr. N. Sujawuddin. Sir, please.
Thank you, ma'am. Good afternoon to one and all present here. On behalf of the organizing team of ICC IDES 2021, I take immense pleasure in welcoming you all for the first session of paper presentation. Congratulations to the authors for their fruitful contribution to research and getting an opportunity to present it in this esteemed conference. It is my honor and privilege to welcome the jury panel members, Dr. T.T. Mrinalini, Professor, CSE, Dr. D. Thenmozhi, Associate Professor, CSE, and Dr. V.S. Felix Enigo, Associate Professor, CSE Department, who have graciously accepted to act as session chairs for ICC IDES 2021. It will be a huge opportunity for the researchers to present their work to the eminent panel members, whom with their in-depth knowledge on diversified areas like artificial intelligence, machine learning, distributed systems, and its applications are sure to give positive suggestions and feedback to take their research work to the next level. Without further ado, let's begin the session with the paper ID number 22, titled Predicting Customer Churn in Banking Based on Data Mining Techniques. I call upon the authors, Cloud Alofi, Haya Al-Bishi, Wafar Al-Subeh, Vaidian Al-Hamdi, and Ayman Al-Yahyan to present their work.
Time, sir?
Yes. So the general instruction is the presentation time is 10 minutes. Discussion with the panel members, it will be 5 minutes. I request all the authors to adhere to the timings. Let's start with the first paper, ID number 22. Over to the authors.
السلام عليكم ورحمة الله وبركاته. I am Wafa Isbai from Imam Abdurrahman bin Faisal University from Saudi Arabia. I would like to thank SSN College of Engineering to giving us a chance to be part in this conference. I will be presenting our paper, which titled Predicting Customer Churn in Banking based on data mining techniques. During this presentation, I will start with introduction, then aim and motivation. After that, proposed techniques, then model validation techniques, and further discussion, finally the conclusion. As we know, data mining is a process of extracting useful information and knowledge from large data sets. There are different fields that use data mining, like engineering, banking, education, sports, medical. Especially in banks, its most important problem is customer churn, which is the customer leaving the bank's service and going to another service provider. So, the main aim of our study, building a machine learning model for predicting customer churn in the banking sector using neural network, MLB, and random forest and decision tree, G48. This study was motivated by helping banking discover the most important features that affect customer churn and increase banking profits due to make the right decision at an early stage to retain the customer. According to the model validation techniques, both 10-fold cross-validation method and holdout validation with different partition ratio methods are systematically used in order to select the best model among G48, MLB, and random forest, which gives the best performance. In our study, data mining techniques using G48 and MLB random forest, Wikidata mining software was adopted. The performance measure considered was accuracy and ROC curve and confusion matrix. The experimental setup contains 4 stages. The first stage, description of dataset. The dataset from schedule and last updated was 2 years ago. To our knowledge, there is no single study that has used the dataset before. Our dataset contained 14 attributes and 10,000 instances. The target variable was a binary variable reflecting whether the customer churn or net churn. The first step in pre-processing data cleaning, we deleting the irrelevant data attributes like customer number, customer name, and row number, and removing outliers by Weka filter. After then, we dealing an imbalanced data set problem using smooth filter. Then we use different transformation methods, like first we do transform the class from numeric to nominal. Then transform 2 attribute combined levels, then transform 1 attribute encode labels. After then discretization 2 attribute binning. So the final data set 11,222 instances and 11 attributes. The second experiment seeks to optimize the classification result by tuning the parameters of MLB and random forest G48. The CFE parameter selection search methodologies for parameters was used to find the optimal parameter selected for the classifiers. In general, as observed, the classifiers performed well. The first experiment when using the optimal parameters. Third stage, investigating the effect of feature selection on the data set. Feature selection based on correlation and infogame method were implemented with recursive feature elimination procedure to find the best subset achieving the highest performance and the most significant features to predict customer churn. After investigating the two feature selection methods, it's evident the best results were obtained by applying both correlation and infogame using all features. The last stage, investigating the effect of partition ratio on the performance of the classifiers. Regarding the comparison between two validation techniques, 10-fold cross-validation and direct partition, the partition ratio using different partition ratio from 50 to 80, the best partition ratio is 80 to 20. At the end of experiment, the partition ratio was compared with cross-validation. The cross-validation score outperformed the partition ratio with an accuracy of 82.60% in the G48 algorithm. Among all classifiers, the G48 performed better than MLB and random forest for predicting customer churn with a good accuracy of 83.55%. The ROC curves indicate that G48 the most appropriate classifier than other classifiers. The ROC curve of G48 the nearest to the upper left side. And the most important measure to check in the confusion matrix below that rate of false negative, Fn. It an increase in its rate adversely affect the bank's profits. The lowest Fn rate was using a random forest and G48 and MLB respectively. The conclusion in our data set in the bank sector was analyzed using data mining techniques, especially classification G48 MLB random forest. Two validation techniques, namely cross-validation and partition ratio, were applied and their results were compared. The best performance required the use of all the features in the all two techniques, correlation and infogame. We used and compared several performance measures, accuracy and precision, recall, and F measure. The algorithm G48 outperformed the rest with a classification accuracy of 83.55%. Finally, I hope my presentation has shown you that blind data mining techniques, especially in the banking sector, is so significant. Thank you so much for your time, and I would like to welcome any question.
Okay. Thank you, ma'am. Yeah, over to the panel members.
Right. Good presentation. Can you explain how you have balanced the data set? Somewhere in your pre-processing, you have shown that you are balancing, right?
Yes, using a smart filter of sampling method.
Yeah, show your slides in the data pre-processing stage.
Okay, okay.
Yeah, this slide. Okay, so this last part is saying balanced data set and your instances are 11,222. how this instances get improved, increased from 9988 to 11222. What sort of balancing you did? How you increased?
Can you repeat the question?
Hello?
Can you repeat the question?
Yeah, the question is like in the first row, last point, balanced data set, 11,222 instances. Previously, you had 9988 instances. Now, after doing some balancing operation, something you did, and you have increased the number of instances. What sort of operation you did on this previous data set to increase this, and what do you mean by balancing there?
Increase the instance.
Yes, ma'am.
Increase the instance.
Yes, that's what ma'am is asking.
And you can also tell about the distribution of data, like what are the number of classes you have and which classes very lesser in number, which classes more in number, so that how did you balance it, how you got this 11,222. Okay, so if you start from data set description, and you can show the data imbalance nature of your data set, and what is the technology, as ma'am said, what is the technology you use to balance the data set, and how it has been balanced. So all these informations you can add on. Okay.
Assalamu alaikum. Assalamu alaikum.
Yes.
Can you hear me? Yes,
Yes,
I'm
yes.
co-author with Wafa. Can I answer this question, please?
Yes, of course.
Okay. So in this answer, ma'am, thank you for your questions. The answer is we are dealing with the smooth filter, which is the oversampling method that increase the data set with the synthetics for the minatory class. We have now two classes, the churn and not churn. The minatory class is churn, and it's 1,222. After we deal applying smooth filter, which is algorithm that adding more synthetics instance at the last in the data set for the minatory class, the percent that we used in the Wika is 100%. Then the data set of our data set is increased from 10,000 to the 11,022, dependent on the minatory depend on the minatory class, which is not churn, which is churn. So we using smooth filter. That's techniques using in data mining for oversampling class. And why we are using oversampling, not we are using undersampling, because we need the data set. We need the instance is important.
Okay, ma'am.
Okay, stop. Another thing is, what is the necessity for in your second row and first column, you are transforming class from numeric to nominal. Is there any reason for that? And you have, and another question is, you have feature selection methods, right? Correlation method and the info gain method. And among the various blocks you mentioned here, in which part you applied those feature selection part?
Okay, can I take your question one by one?
Yeah.
Okay, for the first questions, we are transfer the class from numeric to nominal. As you know, the classification problem should be the class or the target or the output should be as a nominal to consider that as a classification problem. If it's numeric, we couldn't consider this problem as classification. It will be considered a regression problem, and we dealing with our problem customer churn or predict the customer churn as a classification problem, and using different classification problem as we show you, like random forest and G48 and MLB. This is for your first question.
Yeah, and correlation and information gain feature selection is applicable in which part of this block?
You mean in the data pre-processing?
Yes.
No, first of all, in data pre-processing, we prepare our data set, okay, to be suitable to the next step of our investigation. We have different investigation.
Okay.
First of all, we have optimization. We see the impact of the optimization strategy. Then we do other other experiments for like the feature selections. The main concepts of we are doing feature selection that we want to see what's the most influencing factor or most significant factor for that impact on the customer churn. So what is the impact features that make the customer churn from this bank?
Okay, thank you. Thanks for the clarification.
Okay, one more question. In the accuracy, what is the difference between actual value and default value? The performance accuracy measure you are reporting actual accuracy and default accuracy. How do you get default accuracy?
Okay, when final result, as you see in our experiments, it's not only one stage, we have different experiments. First of all, we are applying the classifier MLB and G48 and random forest with the default value. We have parameters for each classifier, the default parameters, and the optimal parameter that we are seeking in our experiments to add more performance for our result in each classifier. We are doing, there is different actually way. In our study, we do CV parameter selections to seek good performance for our results.
No, actually given a data set, by optimal parameters, you will compute some accuracy measure. That's a single accuracy. Then
Actually, maybe the default value is whatever the tool is supporting, the learned parameters they are using as such, and they have fine-tuned with their own parameters. That is the optimal value that is they are claiming.
Yes, yes.
Okay.
And another question, madam. This is a data set you took it from the Kaggle. So definitely some state-of-art approach would be there for the same problem. Would you compare your result with those existing approaches?
As we said before, to the best of our knowledge, there is no paper that dealing with this data set. First time, our paper is the first study that dealing with this data set. And actually, we didn't deal with the same data set. As you see, we have two different pre-processing stage.
Okay. Just to confirm
inshallah,
that.
As a future fork, inshallah.
Maybe you can give this or substantiate this with some literature survey. What are the works that are happened in this field? You can include that. Maybe if we found such things in the literature survey part, that would be better. Okay, so
yes,
even
yes,
you can include
it's in our papers, in
okay.
our papers.
Okay.
But depend on the time. We have limits of time. We can't dealing with the literature review.
Thank you so much, ma'am. Thank you, panel members. If we don't have any further questions for the author, shall we move on to the next paper?
Sure.
So I call upon the authors of paper with ID 37 titled Evaluating Candidate Answers Based on Derivative Lexical Similarity and Space Padding for the Arabic Language. Authors are Sama Ali Al-Azani and C. Namrata Mahender to present their work. Over to the authors. Yeah, please share your slide and start it. Yeah.
Can I start, sir?
Yeah, it's visible.
Good evening, all. I will say to respect to all attendants and chairman. Our title is Evaluating Candidate Answer based on derivative lexical similarity and space padding for Arabic language. We start first point about introduction. Question answering system. In question answering system is built using natural language processing and information retrieval technique use. The process is divided into 4 models: question processing model and document processing, paragraph extraction and answer extraction model. And also we get overview, but in small lines, about Arabic natural language processing. Arabic nowadays is official language in more than 20 countries, and it's considered as a mother language of more than 300 million native speakers. And we get some points as the challenges of Arabic language, as no capital letters, lack of linguistic resources, optional short also for vowels, free order sentences, also in Arabic language, inflectional language as roots in suffix, prefix, like that. In our purpose method, we're talking about how we can measure the distance using Hamming distance. Hamming distance is an algorithm used to metrics for string, but in 2 binary in same length. As example, when we say we talk about here apply Arabic language only as a word. Zira'a and Zarafa is same length, but it's different between strings. So we do measure between model answer and student answer. Model answer means it's data inside dictionary, and the student answer is the answer your student get this in paper. We see here, if we see this 3 different letter, means Hamming distance became 3 strings only. We get some challenges in Hamming distance. It's used only to measure, I say before that, same length. So if the length for student answer increase, Hamming distance is worthless to get correct answer. And correct answer between about answer, student answer and model answer is no any difference as missing, wrong, add in any position. Standard Hamming model also are not considered the answer is correct if about the student answer and model answer have a lexical similarity, and they are derivatives of the same root, such as we say in Arabic يلعب play, لعب played, لاعب player, لاعبة player, for female and male. It's different. There is also other issues related to the articles, like the in Arabic al. This also other issues in when we use Hamming distance. So we get Hamming distance to try to solve these issues by applying space padding pre-processing. We use space padding processing to answer the similar than the other answer. And padding space makes also the text of the length both for answer and model is equal. Also, the purpose Hamming model tried to solve the similarity of an equal answer length by using also space padding pre-processing, and the purpose edit-based model tried to solve issues of the lexical similarity for derivatives of the answer by applying other process stemming pre-processing for both student answer and model answer. Hello?
Yeah, please proceed, ma'am.
Yeah. This standard Hamming distance we see it's appear in this graph. Standard Hamming distance if teacher get question to the student and students start to get answer get their answer go to measure for length for this answer with answer definitely it's in dictionary of model answer. And second things, this standard it's working if the student answer is same with the model answer, it's give me the distance. But if it's not same, it's not get correct distance. So we get purpose Hamming distance to solve this problem. And I say also before that other issues. This purpose Hamming distance we add stemic pre-processing and also space padding processes to solve problem to get correct distance just using Hamming distance. Data collection we use in data collection I will explain briefly from Arabic books in Yemen country from 7 standard, 6 standard, only in Arabic language. Okay, we collect many questions from first, second, second, 6th standard and 7th standard. We see here we get this question. ما هي الحرفة التي كان يعمل بها أجدادنا القدماء في اليمن? What is the craft of our ancient used in Yemen? We get here many answers for this question as farming, farm, farmer. So here every student we get different answer. We try to measure this distance by using Hamming distance because from one to other student he get a different answer. Pre-processing stage, I say before that we use two pre-processing, stemming pre-processing and space padding to solve these problems in standard Hamming distance. First, stemming pre-processing takes about the answer of the student and model answer to remove the articles from the answer and to return all derivatives of the words, the answer to the root of the word. I mean main root. The derivatives of the answer have a lexical similarity with the same meaning. As a second step, stemmed model answer will be stored in the dictionary of the model answer. The purpose model will use the root of the word, makes exactly lexical similarity between the answer and the typical answer. The space padding is applied to the small length of the answer to become equal in the length of the other answer. Processing stage, the main processing of the purpose process Hamming distance takes about the answers of the student and model stemmed answers without space padding in the case same root result from derivatives of the typical answer and the space padding in this case of the different rows result from the different answer of the model, the Hamming operation for the strings. There is no possibility that the two answers are different in the length. Also, in the most case of the purpose model retains 0 value as a distance of the derivatives roots, the purpose model gives equal or greater than 1 as the distance if the missing or wrong in characters. This our algorithm purpose in Hamming model distance is explain all points and results and discussion. The result of the edit base model and is applied in some question. We take only 60 students and apply this new our purpose, and we get achieve 330.3 correct answer with 0 defined distance value and achieved 5 85.3 wrong answer with greater than equal to 1 wrong defined distance value, and achieved 3.8 wrong answer with undefined the distance value. But the purpose of the distance value achieved 75% correct answer with 0 correct defined distance value, and achieved 25% wrong answer with greater than or equal to 1 defined distance value. We see this table, all students answer first this question, and model answer Zara'a is the correct answer, but we see here students, 20 students write correct answer and 10 students write other answer, 7 students also 3, 5, 10, 5. So we get here distance for standard model, Hamming model, and purpose edit model, standard Hamming model, and purpose what the result between two types. First, in standard model, we see Zara'a because it's a correct answer, it gets same 0, 0, but in other answers, we see standard Hamming distance get wrong answer, but our purpose get approximately more answers as a correct answer because we apply stemming and Hamming padding. See this distance for standard model who apply by coding in Python programming, and this distance of our purpose model we see is Hamming distance is 0, 0, 0 because we do improvement for Hamming distance model algorithm. Conclusion and future work. The result of the edit base is applied on the same equation. 60 students, standard model, we say before that 30.3% correct answer, 0, and all measurement I say before that. So in our study, we hope in future do similarity, semantic similarity with the other algorithm, Levenshtein distance. Thank you for all, and I'm ready for any question, and thank you for all attendance for listening.
Thank you so much, ma'am. Over to the panel members.
Okay. I have a question. Like you experiment. Yes. Okay. You experimental result shows for single question. Likewise, what is your data set? How many questions you have considered for your evaluation?
Ma'am, see, we have maybe approximately 1,000 questions. Okay.
Okay. Did you mention in your paper or in your presentation that detail?
No, ma'am, I didn't mention that,
Yeah,
but I mentioned.
Because that is required. Maybe for one question, you have shown the performance, like how your normal Hamming distance will work and how your padding based and stemmed based Hamming distance will work. But it will differ across your number of questions, right? So on average, how many questions were taken, and what could be the mean average? You can measure the mean of the entire questions performance. That is one suggestion we can give. And how did you stem it? Actually, you applied stemming, right? Stemming of the words. How did you stem it? Is there any tool for Arabic language, or how did you stem it?
No, I didn't use a tool. I use Python programming. I use coding for do that stemming about Arabic language.
Okay.
I use coding. Yes.
Okay. Maybe in your algorithm it is shown. You have shown some algorithm, right? Can you show the algorithm?
Yes, ma'am.
You have shown one algorithm.
Yes, I will get it now.
Okay. In this, which part that stemming is happening?
See, ma'am, is there. Step point 2.
This is what I asked. You used some ISRI stemmer. So that is the question I asked you. What is the tool you used to do the stemming?
Yes, I use that as a library in Python and do coding to achieve that.
Okay, this is part of which library your ISRI stemmer is?
Stem process.
You implemented using Python or Java or what language you used? Python. This ISRI stemmer is part of what library of Python?
Steam process. In stemmer.
Yeah, that is the stemmer. But which library you used to invoke this particular stemmer? What library you import? That is the question.
NLTK, ma'am.
Is it part of NLTK? Okay.
Yes, ma'am.
Okay. So those details you can provide. And another question, all your 1,000 questions you have considered, the answer would be a single word answer or the phrase kind of answers also permitted?
No, ma'am. See, in Hamid distance, only use it to one word.
One word answer. Everything is one word answer.
Yes, ma'am. If I will go to
phrases.
Not allowed for phrases. If I will go to phrases, I will use other algorithm like Levenshtein. This from our future work. Levenshtein algorithm that use it for phrase measure resistance.
Similar way, you have not done the semantic part of the answer,
no,
right?
Only here lexical similarity. I will go in semantic in other paper with Levenshtein algorithm.
Okay. That's all from my side.
Thank you, ma'am.
Maybe.
Ma'am, do we have any further questions?
No, sir. I think almost everything is addressed.
Right, ma'am. Thank you so much, ma'am. Thank you so much, authors.
It's okay. Thank you for all. Thank you.
Thank you, ma'am. So next I call upon the authors of paper with ID 23 titled Early Prediction of Diabetes Disease Based on Data Mining Techniques. Authors are Salma El-Sadek, Lama Al-Shairi, Ravan Al-Katani, Zaina Al-Garni, Linda El-Badri, and Ayman Al-Yahyan. Please share your screen and present your work.
Can you stop share, please?
Yes, ma'am. I think now you can share.
Assalamu alaikum. I am Salma Sadiq, a student in Imam Abdurrahman bin Faisal University. I would like to thank SSN College of Engineering to give us this opportunity to participate in this conference. I'm going to present our paper, which titled Early Prediction of Diabetes Disease Based on Data Mining Technique. During this presentation, I will be covering introduction, literature review, methodology, result and discussion, and finally conclusion. Diabetes is one of the most common and frequent diseases in which your blood sugar levels are very high. Diabetes affecting 422 million people globally. By 2013, over 552 million people around the world are likely to experience diabetes. Diabetes have three main types. Type 1, the most dangerous and can cause serious issues. For example, it can damage kidneys, eyes, and other organs. Type 2 and gestational diabetes are not as dangerous as type 1. It can be controlled by organizing meals and making exercises. Diabetes have effects on the economic despite allocating large financial and medical resources to confront it in developed countries. Decisive economic considerations have not been reached to arrest or reduce its costly complications. As many of you might already know, data mining is the process of finding meaningful knowledge from hidden patterns. By extracting knowledge from copious amount of data to identify patterns as well as to establish relationships that help solve problems. Applying data mining technique will facilitate the early prediction of diabetes, which improves the treatment. It can also facilitate the diagnosis for doctors in making their clinical decisions. Then it can be used to create an efficient decision-making process in the medical field. The main aim of our study is to building two data mining models using classification methods, random forest and multi-layer perceptron, to predict diabetes disease, seeking a comparison between the two algorithms, random forest and MLP, to determine the best performance to help forecast the onset of diabetes in the infancy stages using different measurements. Determine the most salient issue that can be impact. The finding can also be used to issue early warning about the disease. Ensuring early diagnosis and attention to avoid complications such as kidney failure, loss of limbs, arterial stiffness, stroke, and heart disease are the most important means to reduce the economic burden of diabetes. This was our motivation to make this research. The majority of the studies conducted so far, machine learning algorithms have been used. The MIMA Indian Diabetes Database was the most widely used. Different algorithms were applied to this database. The result differed from one study to another regarding the best algorithm to apply. In our research, we used a data set recently collected from patients of Sylhet, Bangladesh, based at Diabetes Hospital. Thus far, only two similar studies have been carried out using the same dataset, which are 8 and 9. In our study, we used a data mining technique using MLP and random forest. Weka data mining software was adapted. The performance measure consideration was accuracy rate and ROC curve. The proposed methodology that follows in this paper consists of 3 main stages. Each stage has a series of steps. First, the dataset was extracted from UCI repository and collected using a questionnaire shared with the patient of Sylhet Diabetes Hospital. It contains 17 attributes and 520 instances. The attributes are all nominal except age, which is numeric. This figure, summarizing the preparation approach, we use filters to remove outliers and missing value and transform data from nominal to binary. Intending to optimize the result of classification, we used the CV parameter selection. The optimized parameters of random forest and MLP were determined by adjusting the number of the tree and the seed were resetting. In addition to adjusting the seed, the learning rate, and the hidden layers parameter for the MLP, as per the finding, the accuracy of random forest and MLP was 97.88% and 96.34% respectively. As you can see, in the first table, both default parameter as well as optimal parameters. The other table shows a comparison of finding associated with optimal parameters and that of their default contributors. It can be seen that the random forest accuracy increases, but the MLP remains unchanged. The InfoGain and correlation-based selection of feature methods were used to determine the best performing subset along with the most salient attribute to ensure early prediction of diabetes. The results of InfoGain and correlation-based feature selection method are presented in these tables when using all the 16 feature and the default parameter. This table is clearly point out that the implementation of all features, 16 in totality, helped obtain the best performance. The results have been shown that decreasing the number of features leads to decrease in the percentage of accuracy. This table and figure show the model was used to ensure early prediction of diabetes using 16 features involving optimal parameters. The technique of tenfold cross-validation was used to attain optimal finding of MLP and random forest. Random forest was used to outperform MLP in terms of forecasting diabetes. Its accuracy was found to be 97.88%. The accuracy was negatively impacted when the number of features was lowered and enhanced after using all features. Based on these findings, it can be inferred that it's necessary to incorporate all features to increase the accuracy of forecasting diabetes at an early stage. The ROC curve of random forest is the nearest to the upper left side, which indicates that random forest is the most appropriate classifier than the other classifier. This research focused on the predictive ability of the data mining method in the early prediction of diabetes. The random forest method was found to yield better results than MLB when it comes to enabling early prediction of diabetes with high accuracy of 97.88%. It also outperforms the result derived in paper number 8 in related work, which was found to have an accuracy of 97.4%. The experiment revealed that both algorithms work better when all features are utilized. Therefore, each of these features was used to achieve the highest possible accuracy ratio. As you can see in this table, the 3 papers which worked on the same dataset. We are the only study which compare between MLB and random forest and have this accuracy. Finally, I hope my presentation has shown you that employing data mining technique in diagnosing diseases has significant. The early prediction of diabetes can go a long way in helping people avoid the negative economic consequences that emerge from the constant rise in the number of cases involving this serious disease. I'm open to all your questions. Thank you for attention.
Thank you, ma'am. Over to the panel members.
What type of diabetic you are trying to detect? Is it type 1, type 2, or gestation diabetic, or it's a general model which is not bother about the type?
Can you repeat the question slowly, please?
What type of diabetic? You told type 1, type 2, gestation diabetic and all. What type of diabetic your system can detect? Or it detects only possibility of diabetic or not?
It detects only the possibility of diabetes.
Okay, it won't detect the type.
No.
And what are the feature selection method you used in this?
I used InfoGain and correlation-based feature selection.
Okay, only correlation-based. You didn't use. Why didn't you use any statistical feature selection methods, chi-square method kind of things?
I can add it in the future work.
Okay, because it seems to be simple feature selection method. Maybe along with the correlation method, if you try for some statistical feature selection methods, maybe you can measure the effectiveness of your feature selection also.
A very good point. I will add it for sure in the future work.
And you claim that there are no work for diabetic detection.
What? Can you repeat the question?
Is there any other work for diabetic detection? Did you compare with them?
Yeah, in the related work.
Maybe you can compare it in your final results and performance. Therein you can take the UCI data set. You can measure the performance and you can compare there with maybe you can move those things to the result part instead of saying the literature, because in your literature survey also people have used random forest and other things. You tried something and you try to improve that, so you can place all those informations in the results and performance part instead of writing in the literature part. Generally we write something in the literature to motivate our work, okay, but results comparisons can be moved to the later part, results and discussion part.
Assalamu alaikum, ma'am. About your question, actually it's there in presentation, the page number 15. Please, Selma.
Okay, can you show that?
Show page number 15 and describe this page. The final result between and the differences between our result and
your result and their result.
Please, Selma, speak this.
The final
is there any reason for improved performance you got from them due to your parameter tuning you are claiming? Because in reference number 8 is also using random forest. You are also using random forest and you got a better result than them. So is there any reason for that? What is your conclusion?
We have actually different steps. First of all, we prepared the data set that is found in the UCA. This is the first reason. Second reason, actually, we didn't compare with the optimal parameters. We used some optimization techniques for the random forest.
Okay. So some optimization in the sense you modified your parameter values.
Yes.
So due to that, you're telling that it is the performance is improved.
Yes, depend on our optimization strategies.
Okay.
Thank you, ma'am. Ma'am, any further questions for the authors? Ma'am, panel members, any more questions?
No, sir. You can proceed.
Yeah. Thank you, ma'am. Yeah. So, so next I call upon the authors of paper ID with ID 32 titled Analysis of Land Cover Type using Landsat 8 data. Authors are Samukta V, Sabeshnav M, Krishna Samira A, Aravind J, and Veni S. Over to authors. Please share your screen and start present.
Can you see my screen?
Yeah, it's clear, ma'am. You
Yes.
can proceed. Yeah.
Yes. So a very warm good afternoon to one and all present here. I am Samyukta, a third-year undergraduate pursuing ECE in Amrita University. So today I am so much honored to be amidst the greatest minds. So only the very best people in any field will take the time and make the sacrifice to be a part of an amazing conference like this. And I'm extremely humbled to be part of one. And I extend my sincere thanks to the session chairpersons and the session coordinators for giving their time, for devoting their time to recognize our works. So today I am here representing my team, Sabeshna and Samira, in presenting the paper titled Analysis of Land Cover Types using Landsat 8 data, because the results that my team and I found were quite amazing. So moving on to the next slide. So in the recent article from Economic Times stated that there would be a massive digital acceleration seen in all the sectors in the year 2021. So being an research enthusiast in AI and ML, we cannot neglect the indispensable role played by ML for the digital acceleration. So one such sector that would be greatly impacted is the agriculture. So it is one of the most oldest and the most important professions in the world. Now, if you consider the traditional seasonal practices, farmers, they leave the land fallow for over a period of time and then they recultivate again. And then they leave it fallow and then recultivate. So because of this, they are not able to obtain a maximum produce. So by analyzing the land cover, we would be able to increase their farm produce. So with the help of AI and ML, we would be able to decide the right crop for the right soil and the right time. So here, moving on to the classification. So classification is one of the primary use of data science and in an ML. So these classification algorithm techniques are utilized by different supervised classifiers to develop predictive models. So in our work, we have analyzed the land cover types using Google Earth Engine platform. So now this work of us would be carried out as a previewed work for a future further fallow land classification. So moving on to the literature works. So classification of agricultural lands using remote sensing is a well-studied and implemented area. So one such study was done by Tenkabel and Wu. So they have classified the cropland and the fallow land using the multispectral data from the sensors, but with the low resolution sensors like that of a MODIS. And also in papers like wherein they have to compute the land surface temperatures, they have computed the top of atmospheric reflectance manually. And also, like in most of the works that we have gone through, they have mostly used SVM algorithms for classifying these croplands and the fallow lands. And one such work was Xinzong. So they used SVM to classify their cropland and the fallow land. So our product, so what we would conclude from these literature work is that, So we resolved to go for Landsat 8 data products because we have directly TOA computed products, that is the top of atmosphere correct SR computed products. So this would make the solution more suitable to implement in our real life applications. And also we opted for the CART algorithm because which would work based primarily on the decision trees and would perform our multi-class classifications that we need. Now, so this is a proposal. So before moving into it, we carried out the entire work on the Google Earth Engine platform. So Google Earth Engine is a platform for spatial analysis and visualization of the geospatial data sets. So this has made the computation much more easier and simpler. Now moving on to the data set. So our data set, we have collected a data set from a small town in the district of Erode. So along the banks of River Kaveri. So this is the area that you see here. So this is the ROI. So this snip is from the GEE, the platform that I've taken, that we have used. And so this is our ROI. And so we have particularly chosen this area because this area has all the rich landforms that we require. It has the combinations of agricultural lands, fallow lands. It also has the urban areas and the water body that we require. So this was the area that we chosen for our classification. So yes, and in the image pre-processing. So in the image pre-processing, our data sets are, it has been ordered based on the cloud cover. And we have taken the image that has the least cloud cover. And then we went on to the next process of extracting the features. So features extraction was made much simpler in the GE platform. So we are able to extract the features with the marker tool available in GE. So the feature extraction is performed based on a single label called land cover. And then we have assigned different class numbers to the various features. Like we extracted agricultural land, we extracted fallow and urban and water. So here I have attached two snips of them. So one is the features that has been collected. This is the agricultural lands and this is the urban areas. So this is the feature extraction process. And the next process is the sampling of input imagery. So if you see Landsat 8 data products, they have rich, it is a multispectral band and it has rich set of features, like it has many bands. But we are interested in only few bands. So we, procured only bands 2, 3, 4, 5, 7, and 10. So we took all these bands and then that was, the selection of these bands was done in the sampling of the input imagery. And then in training the classifier, so we have used the CART algorithm and along with this extracted features as you see here, we have trained the model, the classifier model. And now the trained model is used to classify the image. So as you see, this was the result of the classified image using CART algorithm. So yes, so results. So we have, divided a data set into 70% training set and 30% as the test set. And a model is trained using the data set and it is tested with the test set. So we have used the confusion matrix as a tool to, perform the accuracy assessments. So here if you see vegetation, water bodies and fallow, and the other includes like the urban areas and the rest, the other features. So we have acquired an accuracy of 82.3%. And yes. So from this study, we observed that the decision tree algorithms was able to enhance the performance of our model in the GE. And we have planned and we are currently working on employing this base algorithm to a fallow land classification work. So thank you guys. Thank you for your patience and thank you.
Thank you, ma'am. Panel members, floor is open to you guys.
Yes, how do you collected that feature, that is you said feature selection, right?
Yes, ma'am.
How do you did that process?
Yes, ma'am. Ma'am, we have made use of the marker tool that is available in GE. So we are easily able to extract the features from the GE map. So it is a cloud platform, so things are made more easier for us to extract and work on it.
Okay, what are the features you extracted?
Yes, ma'am. We have extracted agriculture, fallow land, urban areas, and the other area, and water bodies. Yes.
Okay, just marking though in those areas, just the features get extracted, right? Or can you explain that process?
Yes, ma'am. Ma'am, we have, when you mark the tool, we extract all the information regarding that particular pixel. The bands, the corresponding values, the TOA values, the particular cloud value, everything, ma'am. We are able to
Can
see
you,
all.
Samyukta, can you describe, maybe in continuation with what ma'am has asked, can you describe the data, like what is your data set size? What could be the schema, like what are the attributes it has? How many instances you have?
Yeah, that will be better. Yes.
Yes, ma'am. So we have procured the data sets from the Lancet 8. So since it is a GE platform, it doesn't take so much time to download because we're not going to download anything. It is available in the cloud. So it has made us processing much faster. So we have procured all the data sets and we have specified this particular
So
ROI.
you need not collect your data set.
Yes,
You are downloading the available data set.
Yes, ma'am. You need not actually, you just importing it here because there is no downloading involved also, because downloading, Lancet 8 data sets are a huge data set, because usually when you go for the usual tools for analysis, like with such geospatial data would be QGIS or ArcGIS or some more. So, but employing GEE would be a much helpful in computing faster.
Samyukta, I think like for the particular area, E-Road, that particular place you download you obtained the data.
No, ma'am.
By mentioning the position or from that area, E-Road, the entire thing you extracted that particular thing.
Yes, ma'am. If you wanna, you have to extract that particular area, you have to go for snapping that particular area. But we have taken the entire Landsat, but we have trained the model for that particular area because we are working. Our envision is only to focus on that area, and later we would be, developing it across the India.
What's the data size you have taken, and what is the data distribution?
Ma'am, data size we are not sure because we are not working on, we haven't literally worked on the data size. We have already imported the data sets. So it is like.
That's what I'm asking you, the size of the data. What is how many images you have, and for each category, what is the size of image, such details.
I think it ranges from GB, ma'am. The data range would be in GBs, but I'm not sure of the exact value.
How many images? How many images?
Such details you can include in your paper also. Okay, so
Sure,
maybe
ma'am,
it would be in GBs. Let it be, but is it 10,000 images or and in the landscape or whatever the categories you have? So how many images with respect to each and everything? The data is balanced or not? If it is imbalanced, how it affects in your performance? All these things can be measured. Okay?
Sure, ma'am, I would include the same.
Yeah.
Excuse me, ma'am. Can I take this question? The data set question.
Please go. Please carry on.
Yes, ma'am. So we have chosen Landsat 8 collection 1 tier 1 TOI reflectance data set, which is available from 2013 to current date. We have chosen our filter range was from May 2016 to October 2016, and we have sorted it based on the cloud cover. And coming to the feature extraction, so since Samyukta mentioned, we have used the tool given in the GEE, in which we have taken like for each feature we have marked 405, like for vegetation we have taken 400 points, and for water 57.
That's what I'm asking.
This is
such details you can include. Okay.
So based on like how much is required for like proper accuracy measurement, we have selected those many points, ma'am, in that particular ROI we have chosen in the region of E-Road. And yes, ma'am, this is the.
Actually, they won't
hello?
download the data set, no, ma'am. They will
Yes.
just extract the features from the cloud point.
Because Google Earth Engine is an cloud-based. It's available online. It's an open source-based platform. So there was nothing to download, ma'am. Everything could be implemented online, and many could collaborate and work on the same code at once. Yes, ma'am.
Hello, ma'am.
Yes, sir.
Yes, yes.
Yes, sir.
Yeah. So I am also one of the authors for this paper. So this is a nice comments we have received. That is particularly you have asked about how many number of images in the data set. So we have acquired the data one for one particular stripe, that is a vertical stripes we have collected through Landsat 8 data. And wherever the region of interest that is based upon that vegetation or fallow or water bodies, we could able to draw the region of interest, and for that region of interest we can able to find out all this feature extraction. So here in this Landsat 8 data, we cannot able to say that is how many number of images are there. It is one full strip.
It's a one full stretch of image from where you did, right?
Okay.
Yes.
In that image, you have number of ROIs.
Points.
So that is fixed, or how will you decide on how many ROI points you are supposed to choose, sir?
So this is based upon our application requirement, ma'am. So here we are interested in vegetation index, the calculation of NDVI. So in this map, we can able to draw the region of interest wherever having a vegetation.
Okay.
So from the vegetation only, we can able to classify the fallow.
Okay. Thank you. Thanks for the clarifications.
Thank you, ma'am.
Okay.
Thank you.
Thank you, authors.
Thank you.
Yeah. So, ma'am, shall we move on to the next paper?
Yes, sir.
Yes. Thank you. So, next I call upon the authors of paper with ID 36, title Rule-Based Combined Tagger for Marathi's Text. The authors are Kalpana Kandale and Namrata Mahendra. Authors, over to you.
Yes.
Please share your screen and start the presentation.
Yes.
Yeah.
Good afternoon, all. My name is Kalpana Khandale, and I am presenting the research article that is entitled as Rule-Based Combined Tagger for Marathi Text. These are the content of my paper. In around 90 million people speak a Marathi language. That is a large amount of information available in Marathi in electronic form, and this information is not in standard format. Many tools available for the normalization of text, but those tools are not supported to the Marathi up to the mark. The tools available in other language are limited to domain specific. Marathi is the work final language, relatively free order language. Word order is typological property of any language. Hence, the study of syntax word order is not complete when there is no discussion on the word order of any language. In Marathi, many words do not follow the strict order in the sentences. For example, here we can see for only one sentence, that is, tomorrow Manoj will give a gift to Ravi. For that sentence, it is so simple for English, but in Marathi, the word order has been changed, and because of this, the part of speech also the change. Here, one example, that is the mandir, means the temple. On the basis of transformational grammar of Marathi language, noun phrase looks like the different meaning. Here you can see that English word a temple in Marathi is called as mandir, and in English word for temple is in Marathi, that is mandira sati. Likewise, the noun phrase look like different meanings. Mandir is different types of suffixes and postposition and into a word when the meaning has been changed. From this example, we can understand the importance of the Marathi part of speech tagger, because when the suffixes and postpositions are added into the word, the tagging of the word will be changed. Here is some previous study which we have studied during developing the part of speech tagger for Marathi text. Then
part of speech tagger is the formal and functional distinction of words, and they are grouped into the different word classes called as the part of speech tagger. There are three types of part of speech tagger. First one is the rule-based part of speech tagger. One of the most useful and oldest technique of the word tagging is the rule-based pause tagging, in which we can use the handwritten rules for tagging the words. Then the stochastic tagger. This tagger is also called as statistic pause tagger. This is include frequency and probabilities of the word. Here we can use the word frequency and encounter the most frequent word which are present in the training set. Then the transformation based tagging, it is also called as the Brill tagger. This allows the linguistic knowledge is in readable form and transform it into one state to another state by using the transformation based rules. The advantage of this tagging, it reduces the complexity of tagging, because in this tagger there is entwine of the machine learning and handwritten or human generated rules are used. Then here is the our proposed system for part of speech tagging of Marathi text. Here we can see the input text. In input text, we have considered 907 sentences were manually created with their possible tags for the developing the part of speech tagger. Then in tokenization stage, we split each word from the sentences. And in Marathi, the words have separated with the white space and the punctuation mark. In Marathi grammar, the tag to the word are assigned on the basis of Marathi grammar rule. Marathi is augmented language. It has 8 types of part of speech, that is naam, sarvanam, kriyapad, visheshan, shabdayogi avyay, kriya visheshan, upayanvayi avyay, and keval prayogi avyay. Then the apply combined tagger based rule. Our aim to develop the part of speech tagger for Marathi, and for that we have used here the combined tagger to train the data. Combination of the tagger is one of the main feature in natural language processing. The importance of combined tagger is that when one tagger is unable to tag the word, then it would be pass another one. It's called as sequential back-off tagging. In our case, we took the default tagger as a back-off tagger, because while we train the unigram tagger, and in case it has not be tagged the word, then it would be passed to the default tagger, and it will tag the word with the default value NN, that is noun. N-gram has 3 subclasses, that is unigram, bigram, and trigram, and also 4-gram and so on. The unigram tagger, as the name implies, that only single word of its context for assigning the part of speech, and bigram is for the 2 words tagging. One is the previous word and another is the current word tag. And there are some rules we have generated for the proper part of speech tagging for each word. There are some rules here. You can see the sample rule, that is for noun, if suffixes or postposition precedes the words, then tag it as noun or NN. Then rules for verb, if noun or adjective or adverb in the sentence, then tag as verb, that is VM. And else noun, adjective and verb in the sentence, then tag it as auxiliary verb, that is the VAUX, and likewise. Here is one example. One of the most useful and oldest technique of the word tagging is the rule-based part of speech tagging, in which we can use the handwritten rules for tagging the word. Here you can see the example, tu jhad lao and tu ghar jhad. In this example, the word jhad has 2 meanings into the different sentences. In first sentence, the word jhad is tagged as noun, that is noun, and in the second sentence it is tagged as verb. The advantage of rule-based tagger is that knowledge-driven tagger and it's built manually. This is the algorithm for our system. Here we can take the input text as a Marathi sentences which are manually created. Then we create the word tokenization for the input text. Then apply the rule-based pause tagger for that tokenized text. And if the tag is not correct, then it go to the again if tag is not correct, then repeat the step 3, that is again go to the rules and check, and then generate the tag. While we developing the pause tagger, we have faced some issues. Some of them are if hyphen or colon encountered in the word like bolta bolta, then hyphen is come across into the sentence, it is treated as the individual token, and bolta and bolta also considered two different tokens. And in segmentation we have faced issue like while we segment the sentence, then the respected person like it is one of the author of Marathi, that is Pula Deshpande, then it segment as word individually. Then tokenization issue, when we tokenize the word like Navi Mumbai, it is the proper noun, but during the tokenization is considered as two different tag like Navi and Mumbai. These are our experimental result. Here we have considered 635 tag sentences are considered for development of the part of speech tagger. We have used 90% training and training data and training data, that are 571 tag sentences we have used for training, and 10%, that is 126 tag sentences we have used for testing purpose. Total 5,717 tagged words we have trained for our Marathi part of speech tagger. And overall result of the part of speech tagger for Marathi is 79.34%. Here you can see one figure that is the result of our Marathi part of speech tagger. In conclusion, word order is a typological property of any language. Hence, the study of syntax word order is not complete when there is no discussion on the word order of any language. Formal and functional distinction of the word, and they are grouped into the different word classes called as the part of speech tagger. Our work is based on the rule base on combined tagger with the unigram and bigram tagger. The work of pause tagging for Marathi is based on the different types of rules. Total 5,715 words tagged during the training process, and the overall result of the pause tagger is 79.34%. In future, we will adding the more data for training for enhancing the performance of the part of speech tagger. Then I would like to thank CSIR DST major project for computational and psycholinguistic research lab facility supporting to this work, and Department of Computer Science and Information Technology, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. And I would also thank to ICCIDS conference to give me that opportunity to present my paper. Then, and these are some references, and thank you.
Thank you so much, ma'am. Over to the panel members.
Nice presentation. I have few questions.
Yes.
You started tagging it, right? So how many rules you have for tagging, or how many tags you have written rule?
Ma'am, for 8 in Marathi, 8 part of speech are available. For that 8, we I have generate or frame the rule.
Okay, so maybe you can list them in the presentation also, like how many tags you have written the rule, and because since you are telling only 8 rules, it could be tabulated. What would be the rule for all the 8 tags? Okay, so that adds something to your thing. And another point is, suppose if your word has a dot, or if there are multiple words with punctuations, you told some methodology to tokenize it, but you have told one compound word like mandir or something, right? So do you really need some kind of stemming before you apply the rule, or how will you handle such compound words? Can you show that slide? Yes, in this slide. Yeah, take the second word or the third word. How will you tokenize this? Because it's a single word. There is no hyphen or there is no dot involved in it. It's a single word. How will you tokenize that? And how will you come up with what type of tag is that?
For this word, we have to generate rule because one word is noun and one word is adjective. Then we have to frame on the basis of part of speech. That is, if the noun and the adjective is near, then it is tagged as noun.
Okay,
Common
but
noun,
but yeah, fine. In this case, the second word and third word, it is not connected with any adjectives, right? So temple is your noun, but it is connected with some PPs like prepositions.
Yes.
So how will I divide this? Will you take the entire word as a noun, or
Yes,
what it is actually?
I will take entire word as a noun.
Maybe my suggestion for you can carry out in your future. You can do some kind of stemming to separate your root word, and then find the tag for that root word, and whatever the suffix you have attached with that, you can find a separate tag for such suffixes.
Yes, ma'am, I will definitely.
Maybe in this mandira matri something you have.
Yes.
In that up to mandir you can stem it and make it as a noun, and whatever the suffix you are adding, you can make it as like a kind of preposition something. Okay, so you can tokenize by means of stemming also. That you can take up as suggestion and you can work on in future, near future. Fine, but you didn't do any stemming before applying rule, right?
Yes. No stemming. I will not. Sorry, I have not applied.
My another doubt, don't you have any parts of speech tagger for Marathi?
Yes, it is available, but for combination of unigram, n-gram, there is no work.
Okay.
Before, yes. And one IIT Hyderabad, the parser is available, but some words are not tagged properly. Then that's yes.
Okay. And one more thing I thought of, because since you have almost 900 sentences you have annotated with parts of speech tagging, so you can apply some sequence to sequence deep learning algorithm that could do better than your rule based also.
Okay, ma'am, I will do.
Yeah. Okay, fine.
Thank you, ma'am.
Thank you, ma'am, for the valuable suggestions. Any further questions for the authors?
No.
Yeah. So, thank you, ma'am. Thanks for the presentation. We can stop sharing the slide. Next, I call upon the authors of paper with ID 38, titled Ontology Model for Spatio-Temporal Contexts in Smart Home Environments. The authors are Srinidhi L, Nalina Devi Kadiresan, and Lata Parameshwaran. Over to the authors.
Yes, just a minute. So can you just let me know whether the screen is visible?
Yes, ma'am. You can proceed.
Okay. Okay, thank you. So first off, good afternoon, everyone. This is Srinidhi over here from Amrita Vishwa Vidyapeetham. So my research work is based on building an ontology model, especially for spatio-temporal context in a smart home environment. So I'm doing this study under the guidance of Lata Parameshwaran ma'am and Nalina Devi ma'am, who are our co-authors. So yes, so first I'll just jump into why we go into a smart home environment and what, why does this research really has to, have a trademark in upcoming ambient intelligence applications. So when we say smart homes, we know that it encompasses of multiple sensors and actuators so that it will, track the activities that is being carried out in a smart environment. So when we say a smart environment, there are many applications such as for healthcare monitoring, especially if you could consider a smart home environment in this COVID situations, then the isolation of person is tremendously more, and it could be used in various branches of applications. So with such smart home environments, there are two types of data that can be captured from the smart environments. One is an obtrusive way and another one is an unobtrusive way. So when I say obtrusive way, it usually means having video cameras for recording users' activities, video and audio, visuals, so to record each of the user activities, which will go entirely on image processing side. And another way is an unobtrusive way, so which consists of non-visual sensors like motion sensors, temperature sensors, item sensors, and some of the door sensors as well. So in this research, we have directed towards unobtrusive way. So the reason why we felt going for unobtrusive way is because of one simple reason is that when a resident is living in their own home, they should not feel any insecurities about what the actions they are doing, and it is necessary that their privacy must not be invaded. So that was one of the main reasons that we went for unobtrusive way of capturing data from a smart home. So yes, so as the title says, it is an ontology model for spatio-temporal reasoning. So ontology model is a kind of knowledge-driven approach, which is a knowledge representation for existing facts. So the first and the basic question that we have encountered is why we are supposed to go for knowledge-based engineering when we have so many data models to do the same applications. So we came up with a couple of differences which proved to be predominantly applicable for ambient intelligence tasks. So one is that with data-driven, there will be model, there will be a set of instructions, and all the data that we fed into it will be a raw facts, and those numerical data will adhere to the instructions that has been carried out or that has been mentioned in the model. So which is mostly a model-based approach. You can also call data-driven model as a model-based approach. So the main source of knowledge in the data-driven is the logic of the tool or the algorithm that has been depicted, and the existing data will act upon it, and there is no logical representation, or we cannot infer the logical concepts from the raw or the importing sensor data with that. So that is where knowledge-driven approach booms, and it gives a much more meaning to the existing data. So what knowledge-driven does is that it will collect the data as a raw facts, and it will convert into concepts such that it will give a semantic meaning to each of the concepts that has been tagged as raw facts before. So what is the reason that we are supposed to go in this category is that it will make the decision making process and the operational part separate, so that when we have two divisions, then the accuracy of the model that we are building based on this decisions that has been carried out using ontology model will be more, and thereby it will also reduce the coupling features between the decision making and the operational part. So that is why we are going to a knowledge-driven model in order to get a spatial and the temporal context in a smart home environment. So why we need, with spatial and the temporal context, what are all the inferences that we can take, and with those inferences, how can it be useful for any other further ambient intelligence tasks? So when we are analyzing it, we found a tremendous amount of ambient intelligence applications that is still going, and it is still booming. So what can we do is that we can create a common layer where these decision-making inferences can be used by all of those applications. So that is where spatial and temporal context comes into the picture. That is, if we were able to map or develop a user-sensor relationship, then those inferences and those results, it can serve as an input to activity recognition tasks, and even for user behavior analysis also. So a set of inferences that we built, which have the highest capacity of serving it as an input to all the ambient intelligence applications are. First is we established a rule in order to have inferences based on user-sensor relationship. And for example, say if a person is working in an if a person is living in a smart home environment, just imagine if we were able to track and trace the path covered by the resident while performing an action, then wouldn't be suitable for applications like activity recognition tasks. And I mean the combined actions will contribute to a particular activity, right? So when we are able to find out what are all the actions and what are all the next path that does a user go, so those kind of inferences will serve as a tremendous decision making results for activity recognition tasks. And also these kind of results can also be has a potential of moving on to sensor optimizations, and also for, as I already mentioned, for activity recognition models. So let us see how all these inferences are made using the ontology models. Yes, so when I say ontology model, then it means that we are representing the set of raw facts into a concept using methods and classes. So why do we go for classes and properties is that there might be certain raw facts that establish a certain relationship between each other, but we will not be able to finalize that this is a relationship that both of these attributes or the raw facts can do. So that is where the ontology model and the knowledge-based reasoning comes into the picture. It will represent real-time facts, and the relationship between them will be represented clearly. And this kind of representation will be useful for any reasoning tasks. And with ontology model, it is developed using a web ontology language, which is proposed by Semantic Web Ontology Incubator. And so the main question is that, okay, so we have a set of facts. So how does this machine understand that these are all the concepts that has been present? So that is where a web ontology language comes into the picture. It is a machine readable format. So and thereby it has a greater machine interoperability, and the domain reusability is also more. So yes, so our problem statement is that given a smart home environment, we wanted to get a set of spatial and the temporal inferences with the help of ontology model and the rule-based reasoning. So yes, so the data set that we have taken is from is a data set called as Kaya2. So it is collected from Washington State University, which is a CASAS testbed from a smart apartment. It is a smart apartment testbed. So the setup that we took here, it consists of 2 undergraduate students living in a smart apartment, and the number of sensors that were installed were around 100, and the number of activities and annotated were around 12 different activities. So yes, so what are all the attributes does this particular data set consist is that it consists of when an event is occurring. I mean, even in the millisecond of the occurrence is also been recorded, and the sensor ID. So for a particular second, which sensor is being triggered on, and what is the status? If it is a motion sensor, whether it is on and off, and if it is a door sensor, whether it is open and closed. So such kind of sensor status has been recorded, and annotation tag of a person causing an event, whether R1 is causing an event or an R or a resident, second resident is causing an event. So such kind of information is what this Kaya2 dataset represents us. So yes, so the proposed architecture is Debigtor. So the process is, it usually comes with a basic data pre-processing. The need for data pre-processing is that we are supposed to fit all these facts into an ontology model, right? So we need some set of standardized and the generalization that is need to be done, such as for motion sensors we have on and off, and for door sensors it will be open and closed. So we can generalize it as into a decimal or an integer value, saying that for on it would be 0 and for off it would be 1, and the same way for door sensors. So this is how this is a basic data pre-processing that is done, and followed by the data pre-processing. I'll explain in detail about how the knowledge-based construction is done in the upcoming slide. So I'll just to give lay the ground properly, I'll just say that with knowledge-based construction, it usually involves converting raw facts of sensor data into knowledge and into a knowledgeable semantic concept, which is in a machine readable format. So once we have a machine readable format knowledge, so from this that is where a huge chunk of data has. So that is where our all set of semantics are possible. So when we have such type of RDF file, we will say that as RDF file, that is resource description framework, where each of the classes and the properties will be depicted as triplets. So with that knowledge, we will use rule-based reasoning. So the rules that are used are SWRL and SQWRL, which is semantic web rule language, and a semantic querying web rule language. So we'll use SWRL rules in order to get the necessary inferences. So here, when I say end user, it is the expert domains. So it is based on the expert's opinion or the expert's needing capability. The rules have been developed. So here we are being addressed to get all the five all the five motivation points that have been described. So we are making it to adhere into that. We are taking the possible spatial and the temporal context from the existing sensor data. So yes, so this is the ontology model that is being built using a Protige tool. So Protige is one of the ontology, or to be more abstract, or to be more abstract, it is a knowledge representation tool. So which consists of which is a platform for us to create, import a particular ontology. So this is one of the ontologies that we have created, and we have been embedded with SSN, that is semantic sensor network ontology, and we have added some of the properties to it. So yes, so this ontology is developed based on some of the disadvantages that we faced in the literature. So there are some papers where either they were left out of resident information, or they might leave the spatial information, or where the platform was deployed. So such kind of information were actually not there. So in order to address that, in order to get a 360 degree of all the, to put all the data into one particular ontology, we designed this kind of ontology. So when we say an observation, so we could say that we will be able to say that whether an observation is eating, and where that eating process is being carried out, and when eating process is carried out, what are all the sensors that are being triggered on, and at what particular timestamp, and what was the sensor value that has been triggered in a particular timestamp. So that is how this ontology model has been represented. So yes, so as I was saying, so in order to construct a knowledge base, these are the series of steps. So first is design of ontology model, which is nothing but the ontology model that I have shown before. So that's the ontology model has been developed using a Protige tool frame. So once the construction of ontology model is done, the main part is that we have to check whether the ontology model is valid, and it adhere to all the logical facts. That is, we have to check whether the created ontology is not erroneous. So in order to do so, we do check consistency checks with help of reasoners. So when I say reasoners, it means that the reasoners are actually built on hypertabular calculus algorithms, so which has the capability to say whether an ontology is valid, and which will give the input to rule-based reasoning, saying that yes, this ontology model is valid, and all the individuals or the concepts that has been inherited with it is also valid. So that type of reasoning capacity is being provided using reasoners. So after construction of ontology, the consistency check is done. That is the first part. So okay, fine. So we have an ontology model. So our underlying approach.
Sorry to interrupt.
Yes.
Ma'am, can you make it fast? You have 2 minutes more.
Oh, sure.
Already you have exceeded 5 minutes.
I'm so sorry.
Thank you, ma'am.
Yeah. Thank you so much for letting me know. So yes, so the next part is to import the sensor data into the ontology model, and for this we used a plugin called a Selfie plugin. And again, the reasoner is being used, and the final output of the ontology model is stored in an RDF format. So yes, so what were all the spatial and temporal context that we were able to think is that with qualitative analysis of spatio-temporal reasoning that has been addressed in the literature, they did not provide the suitable insight of how the rule behaves in a multi-resident living, especially with the concurrent activities. If it is sequential activities, then fine. From starting from begin to end, only the same user is going to perform. But with concurrent activities, there will be a certain unambiguity. So such kind of unambiguity is being overcome using spatial and temporal context using a SWIRL and SQWRL tool. So this is the result that we have provided. So if you could see here, when a person is eating at the same timestamp, we cannot predict whether the eating activity is is happening in the living room or in the right bedroom. So this is where spatial context kicks in. So with the spatial context, we were able to segregate. I mean, we were able to say we took where the activity really begins, and then we assigned it to a platform saying that, so this is where the activities really begin. So can we have a much more interpretation? So when we did that, we had a result saying that with spatial context, we were able to establish saying that this activity happened by so-and-so resident in a so-and-so platform. So this is the significance of spatial and the temporal context. So yes, so the result that I have depicted before, it has a potential of serving it in sensor optimization and many ambient intelligent tasks. So when we wanted to go for user behavior analysis, then we wanted to know how some of the activities interact. So in order to do so, we used Allen temporal relations. So with that we were able to use rule-based reasoning to find out what was the difference between an activity's end and the activity's begin. So with Allen temporal relation, we were able to do that also. So yes, so the main critical part is the validation of the model. So this is, you could imagine the outputs of this as a decision-making process. So in order to if we wanted to validate, the only way we could validate is to compare with the ground truth. So when we're comparing with the ground truth, it means that we are merely comparing the existing facts and the true facts. So there is no probabilistic models that has been inherited here. So when we implement an algorithm with a data-driven method, then the recall value of both would be the same. So the main aim that we didn't go for data driven is that we want this ontology model to get published in semantic web, such that any users or any ambient intelligent users who wants to use such kind of data, all that they have to do is they have to import the namespace of the ontology and they can use it in their environment or in their Python code. So that was a reason that we did that. Yes, so I would like to conclude that this ontology model is being built especially for spatiotemporal reasoning, for so that many ambient intelligence applications could make use of it, and start with when they start using it, they'll come to know how much spatial and the temporal context have the capacity to adhere and provide some differences in their own applications. And some of the references that I have to. And thank you. I'm open to any questions that you have.
Thank you so much, ma'am. Over to the panel members.
Okay, nice flow of presentation, but you could have restricted your introductory part a little bit, and you can focus on your methodology part more, but you have done it in a reverse way. You introduced ontology to the core, and the methodology you rushed up. But anyway, I have only few queries. You took CASA's data set, and how will do you have any automatic methodology of converting that into concepts and relations that is required for ontology, or you fixed the concepts and relations, you just mapped only the instance part?
Yes, so that is one good question. So ma'am, when we take CASA's data set, the attributes, the overall attributes are almost similar. Maybe one or two attributes may increase or decrease, but the attributes are almost similar. So what it is done in here is that we mapped each of the instances to one of the individuals in the ontology model.
So you fixed the concepts and relations, you try to map the instances of the data set to these concepts and relations.
Yes, ma'am. Actually, ma'am, I could also add a bit to that. These concepts are already existing in semantic sensor network ontology. So with those existing facts, we added some more facts in order to club the CASA's dataset with the ontology model.
Okay, and you have built your ontology whatever the way you want. What is the effectiveness of that ontology? Where did you measure the usage of that ontology? Where it helped you? Did you measure the performance of that effectiveness?
Ma'am, when we say ontology, the only way that we could measure is that can we able to reason all the facts without any error, right? So that is where the reasoners comes into picture. So reasoners is where will tell us whether the performance of the ontology is valid or not.
Yeah, actually you could have done like there is an ontology. The effectiveness of ontology can be measured in terms of some questions, like you can ask questions. The ontology can be used to give a correct answer for that by making use of your the knowledge graph, whatever you have built.
Ma'am, that is where our rules comes into the picture, ma'am. So when I say with the spatial context, I mean, am I able to fetch the sensors that has been activated when a user is performing an activity? So that is where the rules
That is
comes
what
in.
how many inferences you made? Is there any details on those measurements?
Yes, so there were around 5 rules that were developed. I mean, each pertaining to 12 activities. So that has been clearly documented in the paper itself, ma'am. I just wanted to give how the spatial and the temporal context, it is giving meaning to each of the applications.
Okay, that's all from my side.
Okay, thank you.
Yeah, thank you, ma'am. Any more questions for the authors?
No.
Yeah.
Okay.
Thank you, authors. Can you just stop sharing your screen? Yeah. We move on to the next paper. So I would like to call upon the authors of paper with ID 47 titled Pixel-Based Adversarial Attacks on Deep Learning Models. The authors are Kavita S., Varun Suresh, Priyadarshini J.R. and Nitya Ratna A. Over to the authors.
Hi, sir. Just a minute. I will share my screen.
Guys, you can limit
yeah.
your timings.
Yeah, make sure that you finish it off within 10 minutes. Priyadarsh, yeah, thank you.
Yeah. Is my screen visible?
Screen is visible, but your audio is very low.
Oh, okay.
Just check on your audio.
Am I audible now?
Audible, but some noise is there.
Noise is there, ma'am.
Okay, sorry. Okay. Now is it fine?
No, not clear.
Not even now. Okay.
Yeah.
This is my audio. Now, is it okay now?
There is some feeble noise with the audio coming in.
Okay. It's near the road, I guess, because of that. Should I start then? Still with the noise?
Yeah. Can you just put your audio to mute and then switch on? Check it out.
Okay now? Is it fine now? Hello? Is it okay now?
Yeah, much better, but still not clear.
Letter present, sir.
Okay,
maybe this will be
So,
resolved.
Priyadarshini, you can carry on.
Okay. Good afternoon, everyone. This is Priyadarshini, and I'll be presenting to you on pixel-based adversarial attacks on deep learning models. So, what are adversarial attacks? So, when you take an image and you make some small changes such that these changes are not visible to the human eye, but it is enough to cause a misclassification, that is called an adversarial attack. So as you can see in this figure that we can see on the screen, we have an image belonging to image of number 0, and we have made some small changes which are not visible to the human eye. But it is enough for the misclassification to happen. So now the image will be misclassified to be belonging to class 9. There are 2 types of adversarial attacks, targeted and untargeted. In case of targeted attack, we always have a class in mind. So if I have, say, an image of number 0, then I have a target in mind, that is number 4. So when I pass the image of number 0, I want it to be misclassified as belonging to number 4. So the misclassifications would be done with this particular target in mind. Whereas in case of an untargeted attack, I just want misclassifications to happen. So if I send an image of number 0, I want it to be classified to be belonging to any other class other than 0. So the motivation behind this paper and project is that deep neural networks have achieved great results in a lot of real-world applications such as facial recognition, medical image analysis, self-driving cars. But say you have a self-driving car, and because of adversarial attacks, a stop sign is misinterpreted to be a left turn sign. Now, this can cause a serious road accident. So through this paper, we are going to devise a lot of algorithms, apply them on a CNN model, and show you that CNNs do not view images as we humans do and are thus vulnerable to adversarial attacks. So the application that we have for this paper is that with the help of these attacks, you can evaluate the robustness and security of your CNN model, and the images that these attack algorithms will generate can further be used to train the model so that your model is more secure against similar such attacks. So how we went, the approach that we went on was we initially studied some pre-trained models and went through some existing attacks, and then we went on to create our own attack algorithms, untargeted attacks on MNIST and CIFAR-10 datasets, and targeted attacks on subset of MNIST dataset. The datasets that we used are MNIST and CIFAR-10. So the MNIST is basically black and white images of numbers ranging from 0 to 9, whereas CIFAR-10, the datasets, it's colored images of belonging to 10 classes. Okay. So there's a brief overview of the attacks that we have performed, and yeah, so let's further discuss them all in detail. So we'll first go with the untargeted attacks performed on MNIST dataset. Now, when it comes to MNIST dataset, there are two kinds of pixels: the pixels that make up the background and the pixels that make up the image itself, the number itself. So we thought, why not we just change the background a little bit? We identified the background pixels, added a constant value to their intensities, and that alone was enough to cause a misclassification of about 68%. So next, what we thought, now we have modified the background, we have got some misclassifications. Let's try modifying the pixels that make up the number. So we identified the edge pixels using the Canny edge detection library, and we applied AES algorithm on the edge pixel and the pixels to the top, left, bottom, and right. So this gave us a misclassification of about 37%. Now, what we identified through this attack is that when we applied AES algorithm, we didn't set a nonce here, because of which the results were changing here and there. So we decided that here on, whenever we apply AES algorithm, we'll be having a fixed nonce. In the next attack, we identified the edge pixels, we identified the background pixels. For the edge pixels, we set a separate nonce. For the background pixels, we set another nonce. And here we got a misclassification of about 89%. And this is the highest misclassification that we got for the MNIST dataset. Lastly, for MNIST, we went with noise addition. So we first applied random noise onto the image and tried to see if we got some misclassification. And since the misclassification was less, we decided that we'll go ahead with the edge pixel modification as well. So we after application of noise, we identified the edge pixels and applied AES algorithm onto the edge pixel and the pixel to the top left, top right, bottom left, and bottom right with a fixed nonce. And this gave us a misclassification of about 32%. Now moving on to the untargeted attacks performed on CIFAR-10 dataset. Now when it comes to CIFAR-10 dataset, there is no distinction between foreground and background. So we decided to skip the background attacks and we went ahead with the edge pixel attack. So we identified the edges using Canny edge detection library once again. And for each channel red, green, and blue, we set a fixed nonce and we applied AES algorithm with these nonces on the edge pixels. And this gave us a misclassification of about 47%. And the other thing that we tried on CIFAR-10 dataset was we generated the heat map. Now, heat map basically helps you identify the important regions in an image. So if heat map was generated for the set image, we identified the important pixels and applied AES algorithm with a fixed nonce. If it was not generated, when we went ahead with identifying the edges and applying AES algorithm onto the edge pixels. This gave us a misclassification of about 43%. So there's the overview of untargeted attacks. As you can see, for MNIST dataset, the highest misclassification was from edge and background pixel modification, whereas for CIFAR-10, it was from modification of edge pixel. Moving on to targeted attacks. So since we didn't get very great misclassifications from CIFAR-10, we decided to focus on MNIST itself and a subset of MNIST on that. So the numbers that we worked with are 0, 1, 2, and 7. So here, in case of targeted attacks, we work with saliency maps. So saliency maps basically tell us what which pixels are important. So here I have an image of number 0. Which pixels are important for this image to be classified as the image belonging to number 0. So there are two kinds of attacks that we perform. One is altering effective pixels using fixed values. So We generated the saliency map for the input image. We generated the saliency map for the target image or the target class image. And we identified the important pixels from the input image, suppressed the intensity, and we identified the important pixels from the target class image and enhanced its intensity. So this gave us great misclassifications, but the problem with this was that the changes, as you can see, are quite visible. So the columns are the targets and the rows make up the input images. So as you can see, the changes are quite evident. So to avoid these changes from becoming evident, we went with the second attack, that is altering pixels with maximum occurrence. So here we generated the saliency for the input image, the saliency for the target class image. And with that, what we did is we identified the saliency that was occurring the maximum. So maximum occurring saliency from the input image, maximum occurring saliency from the target class image. And the pixels which had maximum occurring saliency in the input image, we suppressed the intensity. And the pixels with maximum occurring saliency from the target class image, we enhanced the intensity. So this way, the number of pixels that were being modified, they were less, but the number of misclassifications that were caused also reduced. So this is a summary of the targeted attacks. As you can see, the fixed values gave us a lot of misclassifications, but the changes were a bit evident. Whereas with case of maximum occurrence, the misclassifications were less, but the changes were less evident. Okay. And there's a performance analysis graph. And again, for MNIST, it was for untargeted attacks. Under MNIST, edge detection and background pixels gave the maximum misclassification. For CIPART-10, it was edge detection. And similarly, for targeted attacks, when we targeted class 2, we had the highest misclassification. So to conclude, adversarial attacks are basically when you make small changes that are not visible to the human eye, but are enough to cause misclassification. So through this paper and project, we have devised a lot of algorithms, applied them on CNN models, and therefore we can say that CNNs don't view objects and images as we humans do, and always, so this raises the question of security. So we have to ensure that the models that we develop are, secured against such adversarial attacks. These are some references that we used. Thank you.
Thank you, Priyadarshini. Panel members, questions to the authors? Ma'am? Yes, ma'am.
Okay, actually, can you show the results slide?
Yeah.
And one more suggestions to the others. Meanwhile, your title is saying pixel-based adversarial attacks on deep learning models. So little bit clarity is missing on the title and what you are explaining. Kindly revise the title accordingly.
Okay.
Okay. And that's all. Okay, proceed with
this. This is what is the misclassification? It's a number or what is the metric you use to evaluate your performance?
Basically, ma'am, so this is the target. So we are trying to cause the misclassification to be as number 0. So this is like out of the test images, we had 10,000, not 10,000, we took the images from the 10,000 images in MNIST belonging to 0, 1, and 2, 7. And out of that, 49% got misclassified.
So, okay, so the metric you use is misclassification, percentage of misclassification.
Percentage of misclassification.
Okay.
Okay, thank you, sir. You can proceed to the next paper.
Yeah, thank you, authors. We will proceed on to the next paper. I would like to call upon the authors of paper with ID 48 titled Decentralized Application Using Ethereum Blockchain on Performance and Analysis Considering E-Voting System. The authors are Sriman B and Dr. S. Ganesh Kumar. Over to you, authors. Yeah, the screen is visible. You can start the presentation, sir. Hello.
Sir, my slide is visible. Can I start?
Yeah, you please proceed, sir. Slide is visible.
Okay.
You can start.
Okay, sir. Sir, my research topic is decentralized application using Ethereum blockchain on performance analyzing considering a e-voting system. Myself, Steeman, research scholar, full-time research scholar in Department of Computer Science Department in SRM University. We are going to discuss about blockchain technology using in various applications, and then the blockchain architecture for e-voting system on blockchain layer, and designing a smart contract in Ethereum blockchain, and what and all installation tools and implementation which required for Ethereum blockchain, and conclusion finally future work and reference. When we talking about the blockchain technology, as for my research, I'm focusing on three aspects. First one is distributed ledger, and then second one is validating a block in blockchain, and third aspect is consensus algorithm. A distributed ledger is nothing but transferring data. Transferring data is in the network. All participants can have a similar copy of the database, which is known as a peer-to-peer communication. Instead of using a centralized method, due to some drawbacks and attacks are possible in centralized method, people are moving towards a decentralized method. And then second, as far as using the validating the block in blockchain. Validating a block in blockchain is based upon the cryptographic section. Based on cryptographic section is focusing on security and privacy of data in the blockchain technology. In the blockchain technology, they implemented an hashing technique like algorithm like SHA-256 algorithm, which is known as a one-way encryption algorithm, and then some key mechanism like public key and private key for verifying the transaction in the network. And then third aspect is focus on consensus mechanism. Consensus mechanism is known as immutable data. Immutable data is known as to increase the computation power in the network. Computation power, for example, in this consensus algorithm, we are focusing on proof of work mechanism. Proof of work mechanism is nothing but the miners used to solve a cryptographic puzzles to add a block or to add a transaction in the blockchain network. A miner is nothing but mining the block or verifying the block in the network, or call us a miner. They have a certain set of properties. They should be agree with some conditions based upon the smart contract. And then we are going to discuss about the blockchain version 2.0, which can be used for various industries and various entertainment, which can be possible for many use cases. My abstract is, first I'm focusing my problem statement. First I'm focusing on consensus algorithm, and then second I'm focusing on crypto mining consensus. Consensus algorithm is miner need to solve a cryptographic puzzle, which required a more computation power, we used to set environment to solve a puzzle to solve a cryptographic puzzle, to add a block in the network. And then also they have some certain limitation time. Within 10 minutes, the miner has to be solve the puzzle and then add into the blockchain. And then there are also some attack like 51% attack. 51% attack means 50% of node join together to add a malicious node into the block, into the network. They can be take your entire node in the network. And then also there is some attacks like Sybil attack, collision free attack. These are attacks are possible in consensus, proof of work consensus. And then in proof of work consensus, they used to the crypto mining power. It required more computation power. It required more computation power to solve a mathematical puzzle. Which we need to set a environment like installing a GPU, adding a graphical card to devices which can be to mine the block in the blockchain. Next, and then the key main characteristics of blockchain are decentralized, and immutable, transparency, and then security and privacy based on this three property. We are implemented application which can be used for e-voting system, and then blockchain can also provide a blockchain as a services BaaS for various enterprises like supply chain management system, e-voting system, and then healthcare system, etc. In this paper, I'm focusing on Ethereum platform to build a e-voting system which can be used based on the consensus mechanism, and also in the e-voting system which can be based on a smart contract which can use to run based upon in the e-wallet like account details, and then transaction ID which has been designed by the smart contract. And then finally, we are going to discuss about the vote validating mechanism to add a confirmation vote into the blockchain based upon the voter and then candidate depending in the smart contract. The architecture is focusing on identity management information system, and then the first step is the voter need to submit their proof or details to verify using the identity information, get backing information from the vote DApp system from the backend operation. And then second step is focusing on validating the proof which has given to verify the transaction between the prover and the verifier. And third step is focusing on the smart contract. Smart contract is nothing but the set of parameters or set of label has been designed based upon the parameters which can be support for e-voting system. And then finally, fourth step is focusing on the data finally verified and stored in the blockchain has been uploaded into the cloud storage system. The layer-based architecture for blockchain technologies. The first base layer is focusing on data layer. The data layer is focusing on hashing function which can be used for which come under the cryptography function. And then second parameter is Merkle tree. Merkle tree is nothing but splitting the number of transaction and bundling together into a single hash, which is similar to the aggregation function. And then also we are implemented a asymmetric encryption technique which based on hashing function. And then also we implemented that for each transaction ID, the timestamp which has been uniquely generated on the data layer. And then finally, the second layer is focusing on peer-to-peer network communication between the verification mechanism, and then the prover and verifier need to agree with the verification mechanism. And then third layer is focusing on consensus mechanism. Totally in blockchain we have totally 16 plus consensus algorithm. In this paper I focusing on proof of work. Now recently Ethereum has been updated into the proof of stake algorithm, which based on the stake has been given to be verify a block in the consensus. And then fourth layer is focusing on insensitive layer. The insensitive layer is nothing but the miner have spent time to solve the puzzle. For them, they are giving a reward which is focusing on insensitive layer. And the fourth layer is the smart contract layer. Smart contract layer is focusing on the application or script written to be the parameter which has been support for various parameters libraries or supported for the application. And then in this slide we are going to discussing about a smart contract which in using in Ethereum blockchain. The first step is focusing on the business problem.
Sir, sorry to interrupt. Can you just you are almost exceeding the 10 minutes. Can you just make it quicker?
Okay, sir. In this step, we are focusing on a business problem which can be used for various use cases, and then also the participants which are including in blockchain network, and the network layer which we're focusing on, and then triggering based upon the functions which are given. We are going to support for a smart contract, and finally sixth layer is focusing on business as per the user friendly details. These are all installation and implementation for developing a decentralized application, NPM manager, and Tuple, which is can be used for build a decentralized app. From MetaMask is an online browser which interact between the front end and back end. Kanaj is providing the 10 free Ether account to develop our Ethereum blockchain. And finally, we are conclude with a library called Web3 library, which can be used to produce a front end and back end interaction as being stored in database, and also we are focusing on gas optimization techniques called Zepnin library to optimize without a gasless transaction. And then we implemented this concept in main network and tested in Ethereum application. And the future work, we are focusing on the scalable issue which can handle the blockchain technology, and then cost, price, the miner reward, a decentralized app, and finally the size of the blockchain. These are the references are given there.
Sir,
yes. Yeah.
before you start, because we are running out of time, that's why.
Okay,
Sir, you claim that your work is performance analysis considering e-voting system.
Yes,
So
yes,
where is the performance measures, and where did you measure those? How you are claiming that your Ethereum blockchaining improved the performance of e-voting system?
That only I mentioned here the Web3 library, ma'am. In existing system, they are using that Web3 library, which now in my proposed system, I am using the open Zeppelin library, which can be used for gas optimization without cash transaction. We can do a transaction. In this presentation, I not mentioned that slide, ma'am. That graphical.
Because your presentation title is nowhere discussed here. You said you use some Ethereum blockchain on performance analysis of e-voting. Whatever you have presented is absolutely about the motivation part. But what is the exact work is missing here, and in such case, maybe you can rewrite your title to be study on Ethereum block something, because performance has not been analyzed.
As ma'am, I am not. I include in my paper, but I not mentioned in the slide, ma'am, because
why
I think
is that, sir? Presentation is for that only, right?
Ma'am, actually, I mentioned that in the conclusion we are using the Web3 library, ma'am. With that, I can explain it like that, I think.
Because if no, not like that. But even in your title slide itself, your name itself is missing. That is very, very preliminary things. That's fine anyway. But
yes, sir, you remove this performance analysis, right?
In the title, because that has not been discussed at all.
By that, we can stop this.
Yes, ma'am.
Because that last part is not at all been explained here.
Yeah, the performance analysis, because it has not been discussed, and the business logic, that is the logic that you are going to create in the smart contracts. I do have questions, because the logic that you are going to write for the e-voting system, right? So here you are saying a Ethereum blockchain. You don't need to have any miners, because it is you are the application that you took is e-voting system.
Yes,
so how come the miners comes into picture for the designing this blockchain?
we are going, sir. We did that. We are test with e-voting system, sir. We can use for any application, sir, like healthcare system, any application, sir. But performance align system I mentioned there means instead of using that Web3 library, we are using OpenZeppli library in this sir. We are performance analyze between the Web3 library and then OpenZeppli library, sir. Analyze between that both, sir.
Okay, sir. So
did you tested one more thing? Did you tested?
Yes, sir. Yes, sir. That I mentioned, sir. I mentioned in using that main network I tested.
You tested? No. How do you ensure that e-voting system is secure with your approach?
Ma'am, already existing system they are implemented with Web3 library, ma'am.
So only based on the library you are saying
based upon library only I am tested.
But any study you did or any test you did to test that performance? No, nothing.
Performance
using Web3 you are getting this much.
Web3, Web3 I am getting the performance, ma'am. Based upon the Web3
how do you measure the performance? How did you measure the performance?
By measuring the transaction speed, scalable issue, ma'am. Transaction handling measurement. Using that Web3 library, we can get 6 to 7 transaction speed, ma'am. By OpenZeppli, we can get to 3 to 7 transaction speed, ma'am. That only I mentioned in the future work, ma'am. Scalable issue throughput.
Scalability is different from this performance. Performance in the sense you are saying scalability, not the security wise. You are not testing anything, whether security it is more secure or not.
That is not my part of research, ma'am. I am focusing on scalable only, ma'am.
Okay.
That is not. I am focusing on scalable only.
Okay.
The performance between that Web3 and OpenZeppli, and I'm focusing on the scalable issue, the transaction handling capacity, ma'am.
So better you can retitle your work. Okay. So that.
Okay, ma'am.
Okay.
Thank you, panel members. Please, authors, you just take over the suggestions and proceed further. Stop sharing the screens, Arya. So next, I would like to call upon the authors of paper with ID 52 titled Continual Learning for Classification Problems, a Survey. The authors are Mochita Vijayan and Sridhar SS. Over to you, authors.
Sir, hope that you can hear me.
Yeah.
Is my screen visible also?
Yes. Please confine to the time constraint of a maximum of 10 minutes. Sure. Thank you.
So good evening all. I'm Mochita Vijayan, research scholar at SRM IST. Continual Learning for Classification Problems is a survey paper on 21 existing works on continual learning in artificial neural networks. The survey highlights the inevitability of continual learning and also report the limitations of existing state-of-art neural networks in this regard. So artificial neural networks are currently the most successful machine learning technique for solving a variety of tasks, including language translation, image classification, etc. One weakness of such model is that unlike humans, they are unable to learn multiple tasks sequentially. Continual learning is the idea of learning continuously and adaptively. The main obstacle towards developing continually adapting system is catastrophic forgetting, which is also known as catastrophic interference. Catastrophic interference is a direct result of a major problem in neural network called stability-plasticity dilemma. Plasticity refers to the ability of integrating new knowledge, and stability indicates the preservation of previous knowledge. This paper is a survey on different continual learning strategies used for classification problems, which include regularization strategies, memory, structure, and energy-based models. So catastrophic forgetting happens when an agent learns from non-stationary data stream, meaning that it cannot shuffle the data around to make it IID, independently and identically distributed. Continual learning is inevitable for general AI. Continual learning is difficult due to catastrophic forgetting, as we have mentioned these points in the abstract session. So this is the continuation of the introduction part only, the objectives of continual learning. Humans are intelligent. We wanted to make systems learn like humans and animals. If we wanted to create artificial general intelligence, we have to solve the continual learning with the following objectives. No forgetting or alleviating forgetting to certain extent, limiting looping over data again and again. Agent has a fixed amount of time and limited amount of auxiliary memory, transferring the acquired knowledge to other domains. Efficiency and scalability is another objective. No or limited task information at the test time, because task labels are often not available during deployment of the real world application. So a full replay or full rehearsal completely solves the problem, but are associated with issues like memory exhaustion, which will not work in resource constrained settings, privacy and security issues, and it is not biologically inspired also because humans do not need to learn previously known classes. So how do we prevent or reduce catastrophic forgetting? So these are the strategies which I have surveyed. Regularization-based approaches. Regularization-based approaches, regularization laws is used to penalize the change of parameters that are important to the previous task. And parameterized regularization estimate a distribution over the model parameter, which is used as a prior when learning new data. Knowledge distillation is that transferring the knowledge using the output of the previous model as source label for the current task. Now we have memory-based approaches. Here, people use an extra memory to store some previous data and sometimes an extra model to train a generative model. Here, that is of three categories. Replay or rehearsal methods explicitly retrain on a subset of stored samples by training on new tasks. Pseudo rehearsal models that are data generating models to retrain on the generated examples. And there are constraint settings also because rehearsal might be prone to overfitting of the subset of stored samples. So constraint optimization is an alternate solution. Room for backward and forward transfer setting. The key idea is to only constrain the update of the new task, not to interface with the previous task. We have structure-based approaches, usually add new architectural blocks when they treat new tasks. They actually can be fixed architectures also, because to prevent any forgetting for the previous task in this family, different subset of the model parameters are decided to each task. When there is no constraint on the size of architecture, this can be done by freezing the set of parameters or growing new branches for new tasks, thereby leading to dynamic architectures. And energy-based models at the last. So I will actually go to the first three methods, which is because it comes in line. Regularization, memory structure. So this is 20 papers in survey, which comes in the following field. Some of them are combinations of memory regularization, or sometimes it is combination of regularization structure, like that. So these are the existing works of continual learning and classification tasks. So this is a detailed illustration of continual learning strategies. There are subcategories and example methods which I have surveyed like 20 papers here in the list. Now, this regularization-based methods, memory-based methods, and structure-based methods have some limitations. Regularization-based method gradually reduces the model capacity for learning new tasks, but then it consistently fails in fast incremental learning scenarios. Memory-based methods need an extra memory, extra model. Sometimes the scalability when the number of tasks increases is questionable. Quality of the sample generated is another drawback because we have to go to the risk of that again. Structure-based methods has an architectural growth. It is restricted to task incremental learning settings. Here we have the energy-based model. So before coming to the energy-based models, the other models that we have discussed are using softmax classifiers. Here the energy-based model. When we have a task, the prediction should be uniformly distributed over all the tasks, which is not the case of the other models. So for the other models, whichever probability comes at the last, that chances of that class getting displayed as the output is more. But here they use a energy function, which actually has a natural characteristic of dealing with the continual learning. And if the input X and label Y is matching, it is a positive pair, otherwise considered as a negative pair here. So minimize the energy of positive pair and maximize the negative pair. So it is a contrastive diverging training procedure which is being used. Let's move on to the research gap. This is what I identified by surveying these papers. The model should be capable of learning both from stationary and non-stationary data stream, because in real world, data is not independently identically distributed. Data streams like MNIST and permuted MNIST, which are used in most of the papers, are highly unrealistic because we experience and learn from temporary correlated data. So choose temporary correlated data sets like Stream 51, which is a new data set for these kinds of experiments. Evaluation of the existing continual learning is mostly done on toy data streams, which comes in line with the previous point. Models that work well in MNIST, CIFAR, etc. tend to fail in other important paradigms because MNIST and CIFAR are small data sets. Algorithms that work well in MNIST may not scale up to large data sets with natural images. Animals and humans do not loop over the enormous batches of data for learning. Data sets selected should be hard and of high resolution. Minimum of 1,000 classes has to be there. Memory and computation must be kept fixed across the model to enable a fair comparison, which is not done in most of the cases because the mounted memory and compute is required in constrained resource settings. Many has hidden costs keeping batch in memory, unlimited compute, etc. And the last point is evaluation of the model in terms of task incremental learning, domain incremental learning, and class incremental learning can only be done when there is a clear-cut boundary for tasks. Using task label makes the problem more easy and also have very limited application. So we will also have to consider tasks without clear boundary. So this is the conclusion. The data collected from the real world may not be always explicitly labeled. The agent should learn from unlabeled data and even should be a recipient of tasks without clear-cut boundaries. And catastrophic forgetting is not only the barrier of general AI. Not every task has a huge data set, and the challenge is to make the models learn from more than just from the samples. Thank you so much. Thank you for the opportunity.
Ma'am, can you show the list of references?
Yes, ma'am.
Okay. Can you just briefly tell how this continual learning differs from traditional learning and deep learning? Just in short, you would have discussed in your slides. Maybe you can summarize that.
Yeah, yes, ma'am. Normally, if we give a task to a deep neural network, it can perform that task well while fine-tuning the networks and arranging the parameters and all. But then what if we give a second task to the traditional neural network? Will it perform well? So if it is coming from an independent and identically distributed data, it has fair chances of performing well because it comes from the same distribution. But then if we train a network on ImageNet data set and then we wanted a ResNet data given to the deep learning models, it won't work in that way because both of them come from different distributions. So continual learning means along with learning series of tasks, it should be able to incorporate more tasks into its base. That is what I find out the difference between.
How can you differentiate this with the transfer learning?
And transfer learning is coming as a subset of continual learning only because that is also required. So when we train a model for a particular problem, that model constraints and parameters has to be transferable to the other model if required, if it will work well for that particular new task.
And you have listed the research gaps. Probably you can include a slide or content on research insights. What do you want to give it to the researchers of this continual learning for you have identified the limitations, gaps and all. Maybe from this precisely I'm not able to pick up any problem statement or what could be the research insight from this. So that also if you include in your paper or in your slide, it would be better.
Okay, ma'am. Thank you, ma'am. Thank you for the comment.
Fine.
Yeah, thank you so much, ma'am.
Okay.
Yeah, we have come to the end of the session, and the last paper I would like to call upon the authors of paper with ID 43 titled Automatic Deduction of Building in Medium Density Image Using Morphological Operation, and the author is Karuna Kirwale. Ma'am, you can stop sharing the slide, ma'am.
Yes, sir.
Over to you, ma'am.
இதுக்குள்ள பிரசன்டேஷன் கேள்வி எல்லாம் முடிஞ்சிருமா? நான் கேட்க
Sir, am I visible?
Yeah, it is visible, ma'am. Can you just put on full screen mode and start the presentation?
Okay, sir. Okay, fine.
Yes, ma'am.
Good afternoon to all of you. My name is Karuna Kirwale. My paper ID is 43 and my entitled as an automatic detections of the buildings in medium density image using the morphological operations under the guidance of the Dr. Seema Kautekar ma'am and R.R. Deshmukh sir. These are the contents of today's presentation: introduction, motivation, objective, literature survey, data and software, methodology with the result discussion, conclusion and references. So since we are dealing with the automatic building detections, it is a now era, it is the active research trend in remote sensing areas. While we are dealing with the identifying the buildings from the high resolution images, we have to separate those images from the backgrounds. And for that, we have the standard method from the literature survey. We have assuming that the object which is having the 4 edges, that is considered as an buildings. This will help us to determine the damage after the natural disaster, wars, then defense system, city plannings. In so many areas, these are going to be very useful. It will also helpful for creating the large scale map also. For it will also it will also helpful for time reducing and cost reducing. So these are some building structures. So while seeing some high resolution images, these am I audible?
Yes, ma'am.
Hello.
Yeah, carry on, ma'am.
Yes. These are some images which is having the different structures of the buildings within a high resolution images. From these images, we can conclude that the buildings can be identified with the help of the edges, roofs, whatever the roof structures will be available for the particular buildings. From that, brightness, contrast, shape, size, directionality. So these many features can be identified the building in a particular image. So we are motivated from these many factors. So first of all, as the population increases, the requirement of the shelter increases, and hence the residential area is also increases. So need of the mapping those areas. The second thing is my native place, that is Aurangabad city is selected one of the Amritsar scheme city. So smart cities for the smart city planning, and building detection can be useful for the income tax office too. In urban area, mostly complicated building detection is a complex problem while dealing with the high resolution images, and building detection get appreciated as a smart city concept is introduced. So our main objective is to extract the zone-wise buildings from the high-resolution image from the Aurangabad city or in any cities. Find the individual and total area acquired by the buildings, and accurately finding the shape of building shapes. Now, then after we have to actually we are dealing with the medium density images. While these 3 images will explain the what type of density of the building available in the particular thing. The dense area, the locality of the buildings were very far. Medium density is the density of the frequency of the houses get increases, and in high density area it is very nearer, closer density of the buildings will be available. We are going for the medium density area. So from the literature survey, we have concluded that there is a lot of work carried out for the building detections from since last 2 decades. They were using the ERDAS, ArcGIS, QGIS, and many more softwares. with the different accuracy, with the different high resolution images. The age detection, morphological operation, classification, and so many techniques are useful for the building detections. And high resolution images with a different sensor like ICNOS, GeoEye-1, WorldView 1, WorldView 2, BigWorld, Aerial are used with the different resolution ranges from 1 meter to 30 centimeter. Means while we are dealing with the building detection, the resolution of the image should be 1 meter to 30 centimeter lower as the 1 meter to 30 centimeter, and the scope is found in many aspects with the review for the research. So we the data and softwares for the particular paper we have used the Google Earth Pro images with the high resolutions, and the software we have used the NV and MATLAB. These are the methodology that we have used. Firstly, we have inverting our image to get the better appearance for the object. Then binarize this image. After that, we have applied the thresholding, Oster thresholding to extract to highlight the image buildings with that particular threshold value. Then after we have applied the median filters for removing the noises in the sense we have considered as in a small object other than the buildings that are we are considered as an noises for the filters, and we have used actually 3x3 filters for removing those objects. Then after we have used the morphological operations, we have used the fill operations for the filling the holes, whatever the find out or hole or gaps in the particular find out rectangles, and then we have applied the morphological opening operations. The regional descriptor will describe the boundaries of the particular rectangular, and then after that we have count the buildings. One rectangular area considered as one buildings, and hence we have get the total we have counting total buildings, total rectangulars available into the particular image. So this is the flow of our methodology we are going from for the particular process. So these are the 3 images we have taken for the this is the subset whatever we have captured from the Google Earth images. So these are the 3 places from Aurangabad city itself. It is Samarthnagar. First one image is Samarthnagar, then the Sangeeta colony, then the Vedant Nagar. So these are the three images where we have considered for our experiment. So these are the outputs while we are taking the threshold value and while after the taking the morphological opening operations. This is the started image, complemented image, and then after the original image, whatever the result we have getted with the help of extracted with the buildings. So this is for the Samarthnagar. This is for the Sangeeta colony, same threshold value, morphological operations, complement started image, and the original image with the building to be extracted. Building is extracted with the building extracted. Same for the Vedant Nagar too. Then the experimental and result discussions for the Google Earth Pro images. Where here we are manual accuracy assessment method were carried out. For that, true positive, true negative, false positive, and false negative concepts were used. Where true positive we are considering the manual and automated method to be classified object as a buildings. True negative is true negative means automated and manual both are not classified as a buildings. Then false positive, where automated method classified as an area as a building but not a manual, and false negative, manual method classified as a building, not automatic. So we also apply some statistical measure. We are finding the branching factor, missing factor, and building detection percentage. For branching factor, we have calculated the false positive divided by the true positive, and missing factor false negative divided by the true positive, and building detection percentage, accuracy percentage were calculated with the help of the 100 into true positive divided by true positive plus false negative. So these accuracy statistics were implemented in the table. So we are considering the three images, that is Samarth Nagar, Sangeeta Colony, Vedant Nagar. So the total buildings available are the 429, 570 and 362 with respect to Samarth Nagar, Sangeeta Colony and Vedant Nagar, and the accuracy we have gated 91.67, 88.89, 87.70 for with respect to Samarth Nagar, Sangeeta Colony and Vedant Nagar. Overall accuracy we have gated 82.75%, and the missing factor we get the 21.21% here. From hence we get concluded the building detection can be useful for the smart city concept. The morphological operations performed identifiable with the median filters followed by the Austin's method. This count of the buildings will be verified by technical department of
right.
Yes, ma'am.
The two things I want to suggest. One is like you were mentioning medium density images. You check the literature. I think that you have to mention it as high resolution, low resolution, medium resolution. Okay, somewhere you have included in your presentation also. Kindly say that. And as per your approach, apart from the building, some other concrete structure, say for example road, and other things, river, bridges, everything's also be considered as a building. How will you avoid that? That also you have to take into consideration. Okay, that is the suggestions.
Okay, yeah, ma'am, we are working on that only, ma'am. Actually, this problem is occurred with us also, so that's why we are working with this to avoid how we can avoid.
Okay, thank you.
Thank you, ma'am.
Sujadin, sir. Hello?
Yes, ma'am. Thank you, ma'am.
That's
yeah.
We can.
Yeah, we have come to the end of the day and the end of the session as well. Ma'am, can you please stop sharing the screen?
Yes, sir. So 1 minute, sir.
Yes, ma'am. So before I conclude the session, I would like to, I request all the participants to turn on your camera so that we need to take the screenshot of the participant and the entire session. All the participants, please turn on your camera. Yeah, participants, can you please turn on your camera? Yeah, participants, yeah, we are coming to the end of the day. Can you please turn on your camera so that we can wind up faster? Right. Meanwhile, yeah, I take privilege in giving the vote of thanks. Yeah, some people are yet to turn on their camera, so Bala sir, Suresh sir, snapshot you'll be taking it, right?
Yes.
Okay, sir. Yeah. So yeah, let me do the honors of giving vote of thanks. First of all, I thank the Almighty for making the day a good one. I thank my profound thanks to the session chairs for giving their valuable suggestions to all the authors and for pursuing them to go to the next level. And my sincere thanks to all the participants who have shared their knowledge and ideas in many very interesting presentations. Yeah. Last but not least, I thank all the organizers and all the participants, students, all the people who have worked out to make this day a grand success. Thank you, one and all present here. And a small announcement, tomorrow we'll meet at 9 hours